Hello, this is section 11.1, Simplifying Expressions with Integer Exponents. Integers are numbers that could be positive, negative, or zero, and these numbers cannot be fractions or decimals. So, when we will simplify expressions in this section, we will not see any fractions or decimals in the exponent. Instead, we will see only integers. Then let's start by reviewing the laws of exponents. The first one is a to the power of m multiplied by a to the power of n equals a to the power of m plus n. This law tells us that if we multiply two expressions that have the same base, and in this case the base is a, then we just add the exponents. In the example to the right, x to the power of 5 multiplied by x to the power of 3 equals x to the power of 5 plus 3, which makes x to the power of 8. The next law is a to the power of m divided by a to the power of n equals a to the power of m minus n. So when we divide two expressions and they have the same base, then we will subtract the exponents. In the example to the right, x to the power of 7 over x to the power of 3 equals x to the power of 7 minus 3, which makes x to the power of 4. The next law is a to the power of m raised to the power of n equals a to the power of m times n. In the example to the right, x to the power of 5 raised to the power of 3 equals x to the power of 5 times 3, which makes x to the power of 15. In the next law, inside the parentheses we have a product of a and b, and this product is raised to the power of n. Then, when the parentheses are removed, a is raised to the power of n, and b is raised to the power of n. To the right, in parentheses x times y to the power of 2 equals x to the power of 2, y to the power of 2. In the next law, we have a fraction a over b that is raised to the power of n. Then here a will be raised to the power of n and b will be raised to the power of n. In the example to the right, x over y to the power of 8 equals x to the power of 8 over y to the power of 8. Next, a to the power of 0 equals 1. An example is 7 to the power of 0 equals 1. Then a to the power of negative n equals 1 over a to positive n. So if we have an expression that has a negative exponent and we move this expression down to the denominator, then this exponent becomes positive. The example to the right is x to the power of negative 4 equals 1 over x to positive 4. The next law is 1 over a to negative n equals a to positive n. So here, if in the denominator we have an expression with negative exponent and we take this expression and we move it up to the numerator, then the exponent will be positive. Then 1 over x to negative 5 equals x to positive 5. And the last law we have here is a over b to negative n equals b over a to positive n. As you see, if we flip the fraction, then the exponent changes the sign. 4 over x to the power of negative 2 equals x over 4 to positive 2. Now we will use these laws to simplify expressions. In the first example, we will simplify the expression x to the power of 8 times x to the power of negative 5. When we simplify expressions, we have to make sure that the answer does not have any negative exponents. Instead, all the exponents have to be positive. In this expression, we are multiplying x to the power of 8 by x to the power of negative 5. So we are multiplying two expressions that have the same base, therefore we will add the exponents. Then we will have x to the power of 8 plus negative 5, which makes x to the power of 3. So in this example, we used the law a to the power of m times a to the power of n equals a to the power of m plus n. In the next example, we will simplify the expression x to the power of negative 7 over y to negative 2. So we have a fraction, but in the numerator the base is x, and in the denominator the base is y. This means that we cannot combine those exponents together. Instead, we will work on making those exponents positive. If we start a fraction, and if we move x to the denominator, its exponent will become positive, and if we move y to the numerator, then the exponent of y will also be positive. Then we will get y to the power of 2 over x to the power of 7. So here we applied the following laws. A to negative n equals 1 over a to positive n, and 1 over a to negative n equals a to positive n. In other words, if we have a negative exponent in the numerator, we will move this expression down and the exponent will become positive. And if we have a negative exponent in the denominator, we will move this expression up and the exponent will become positive. Here we will simplify the expression 4 to the power of 3 times 5 to negative 5 all to the power of 2. As you see, inside the parentheses we have a product, and each of these factors will be raised to the power of 2. Also, each of these factors already has an exponent. 4 has exponent 3 and 5 has exponent negative 5. Then we will use the following law. A to the power of m raised to the power of n equals a to the power of m times n. This means that when we raise 4 to the power of 3 to the power of 2, we will multiply 3 and 2. And the same we will do with 5. So this will be equal to 4 to the power of 3 times 2 times 5 to the power of negative 5 times 2. Then we will get 4 to the power of 6 times 5 to the power of negative 10. Now we have this product, and 4 has a positive exponent, but 5 has a negative exponent. Therefore, we will move 5 to the denominator and we will make the exponent positive. So all this will be equal to 4 to the power of 6 over 5 to the power of 10. As you see, we moved 5 to the denominator and the exponent became positive. And now the problem is completed. If we wanted, we could use a calculator and raise 4 to the power of 6 and then raise 5 to the power of 10. However, we will end up with pretty large numbers, so we could just leave the answer as it is. In the next example, we will simplify 4x squared y to negative 5 all to the power of 2. Inside the parentheses, we have three factors, 4, x, and y. We need to raise each one of them to the second power. This means that we will apply the law ab to the power of n equals a to the power of n, b to the power of n. And because x and y have exponents, these exponents will be multiplied by 2. We multiply these exponents because of this law. So then, let's start by raising 4 to the power of 2. That will be 16. Then x squared raised to the power of 2 will be x to the power of 4, because we are multiplying the exponents, 2 times 2. So let's write x to the power of 4. Now y to the power of negative 5 raised to the power of 2 will be y to the power of negative 10, because we are multiplying negative 5 and 2. So let's write y to the power of negative 10. Now here we have three factors and one of them has a negative exponent. Then we will start a fraction. We will leave 16 and x to the power of 4 in the numerator, but we will move y down to the denominator and the exponent will become positive. So each time we simplify these expressions, we have to make sure that we don't have negative exponents in the answer. In this example, we have 5 times, in parentheses 2, x to negative 6, y to the power of 3, all raised to negative 3. Just like in the previous example, all that we have inside the parentheses will be raised to the power of negative 3. So then, let's bring down 5. Then we will raise 2 to the power of negative 3. Then x to negative 6 raised to the power of negative 3 will be x to positive 18, because negative 6 times negative 3 is positive 18. Then let's bring down x to the power of 18. And now the last one, y to the power of 3 raised to negative 3 will be y to the power of negative 9, because 3 times negative 3 makes negative 9. So we will bring down y to the power of negative 9. So now we have 4 factors, that is 5, 2, x, and y. Out of these 4, 2 and y have negative exponents. Therefore, we will keep 5 and x in the numerator, but we will bring down 2 and y. So let's start a fraction. Keep 5 and x to the power of 18 in the numerator, but bring down 2 and change the exponent to a positive, and bring down y and change the exponent to positive. We can also write 2 to the power of 3 as 8, because 2 times 2 times 2 is 8. Then we will have 5 x to the power of 18 over 8 y to the power of 9, and this will be the final answer. In this example, we will simplify negative 15xy all raised to the power of 0. We know the following law: a to the power of 0 equals 1. Therefore, negative 15xy to the power of 0 will also be equal to 1. So then, let's write that the result is 1. As you see, each time we raise a non-zero expression to the power of 0, the result will be 1. Now, let me show you a couple of examples where this law is applied, but the result will not be 1. Let's say we have 5x to the power of 0. Unlike the expression above, this expression does not have any parentheses. Instead, we have a product of 5 and then x raised to the power of 0. So here only x is raised to the power of 0. Therefore, we will bring 5 down, multiplied by x to the power of 0 is 1, and 5 times 1 is 5. But if we would have 5x in parentheses, and all this would be raised to the power of 0, then here the result would be 1. And that is because the whole expression is raised to the power of 0. Let's see one more example. Negative 3 times 4xy all raised to the power of 0. As you see, negative 3 is not part of the parentheses, so let's bring it down. But then 4xy to the power of 0 will be 1. And then negative 3 times 1 will be negative 3. In this example, we will simplify x to the power of negative 2 plus y to the power of negative 2. Now, if this would be a product of x to negative 2 and y to negative 2, then I would just move both x and y down and make their exponents positive, and I would be done. But in this example, I don't have a product. Instead, I have a sum. Therefore, we need to work on each of these terms individually. To make the exponent of x positive, we will start a fraction. We will leave 1 in the numerator, we will move x down, and the exponent will be positive. Now we will do the same with y. We will write y to negative 2 as 1 over y to positive 2. Now, to add these two fractions, we need to have the same denominator. The first fraction has the denominator of x squared, and the second one y squared. The least common denominator will be the product of these two denominators, x squared, y squared. So then, now both fractions will have the same denominator, x squared, y squared. Now we need to find the new numerators for these fractions. In the first fraction, the denominator was x squared and now is x squared y squared. Therefore, we will multiply the top and the bottom by y squared. Then 1 times y squared will give us the new numerator of y squared, and the denominator x squared times y squared will give us x squared y squared. So then, let's write the new numerator of y squared. In the second fraction, the denominator was y squared, but now is x squared y squared. Therefore, we will multiply the top and the bottom by x squared. Then 1 times x squared will give us the numerator of x squared, and y squared times x squared is x squared y squared. So let's bring down the new numerator of x squared. Once we have the same denominator, then we can add the numerators. Then the result will be a fraction where the denominator is x squared y squared, and in the numerator we will add y squared and x squared. We could also write x squared first, then y squared. So the final answer is x squared plus y squared over x squared times y squared. In this example, we will simplify 3 times 5 to the power of negative 2x times 5 to the power of x over 3 all to the power of 3. First, we will bring down 3 and 5 to the power of negative 2x. Then we will raise this fraction to the power of 3. So now we will have 3 times 5 to the power of negative 2x times, then 5 raised to the power of 3 will be 5 to the power of 3x because we are multiplying these two exponents. So in the numerator we will write 5 to the power of 3x. Then in the denominator 3 to the power of 3 will be 27. So we will write 27 in the denominator. Now let's see how we can simplify this expression from here. We will write the first expression over 1 so that it looks like a fraction. Then in this product we will divide 3 and 27 by 3. 3 divided by 3 is 1 and 27 divided by 3 is 9. Then in the numerator we have a product of 5 to the power of negative 2x and 5 to the power of 3x. Because the bases are the same, we will add these two exponents. Then in the numerator we will have 5 to the power of negative 2x plus 3x, and in the denominator we will have 9. Negative 2x plus 3x is 1x, so we will have 5 to the power of x over 9. And this will be the simplified expression. In this example we have 5 to negative 3 multiplied by the expression x to negative 3 minus 4x all raised to negative 1. As you see, this expression represents a product. The first factor is 5 to negative 3 and the second one is this parenthesis raised to negative 1. And because this is a product, we can move each of these factors down to the denominator and make negative 3 a positive 3 and negative 1 a positive 1. So both exponents will become positive. So then, let's start a fraction, and in the numerator we will have 1, but in the denominator we will have 5 to positive 3 and x to negative 3 minus 4x to positive 1. From here we can write 5 to the power of 3 as 125 because 5 times 5 times 5 is 125. Then inside the parentheses we will write x to negative 3 as 1 over x to positive 3 minus 4x, and then we don't have to write the exponent 1. Now in the denominator we will remove the parentheses by distributing 125. Then we will have 1 over 125 times 1 over x cubed will be 125 over x cubed. Minus, and 125 times 4x will be 500x. Now what we have here is a complex fraction. A complex fraction is a fraction that has fractions in the numerator or in the denominator, or in both? In our example, this fraction has a fraction in the denominator. To simplify a complex fraction, first we have to find the least common denominator of all the denominators in the individual fractions. The only fraction we have in this complex fraction is 125 over x cubed. And the denominator of this fraction is x cubed. Therefore, the least common denominator will be x cubed. From here, we need to multiply the numerator and the denominator of this fraction by x cubed. So here to the right I rewrote the problem, and now we will multiply the top and the bottom by x cubed. The numerator will be multiplied by x cubed, as well as the denominator. Then in the numerator we will have x cubed, and in the denominator we will use distributive property to remove the parentheses. When we multiply x cubed by 125 over x cubed, then x cubed and x cubed will cancel, and we will be left with 125. So let's bring down 125 minus, and now we will multiply x cubed by 500x. That will be 500x to the power of 4. So then in the denominator we will have 125 minus 500 x to the power of 4. And now this is how far we can go with this problem. In this example, we need to simplify the expression x to negative 1 plus y to negative 1 over x minus y to negative 1. So as you see in this expression, in the numerator we have a sum, but in the denominator we have a difference. And because some of these terms have negative exponents, we will turn them into fractions individually. So let's start a fraction. And this x to negative 1, we will write it as 1 over x to positive 1, or just 1 over x. So here we have 1 over x plus, and we will do the same with y to the power of negative 1. We will write it as 1 over y to positive 1, or just 1 over y. In the denominator, let's bring down x minus, and y to negative 1, we will write it as 1 over y to positive 1, or just 1 over y. Now we have two fractions in the numerator and this fraction in the denominator, and we could also write this x as x over 1. And now as you see, we have a complex fraction because we have fractions in the numerator and we have fractions in the denominator. From here, we have to locate all the denominators and find the least common denominator. The denominators we have are x, y, 1, and y. Then the least common denominator will be x times y. So the least common denominator has to be a product that contains one of each of these denominators. In other words, we can say that x goes into xy, y goes into xy, 1 goes into xy, and y also goes into xy. I will rewrite the expression we have one more time. 1 over x plus 1 over y over x over 1 minus 1 over y. Then we will multiply the numerator and the denominator by xy, which is the least common denominator. We will distribute xy to remove the parentheses, and you will see that after this step we will not have any more fractions in the numerator or in the denominator. So then, let's start with the numerator. When we multiply xy by 1 over x, x and x will cancel and we will have just y. Then in the numerator we will write y plus, and now when we multiply xy by 1 over y, then y and y will cancel and x times 1 will be just x. So then in the numerator, let's add x. Let's continue with the denominator. We will multiply xy by the first fraction and again xy by the second fraction. When we multiply xy times x, nothing will cancel because they are both in the numerator. Instead, we will have x squared times y. Then we will write x squared y. And at last we will multiply xy by 1 over y. In this case, this y is in the numerator, but this y is in the denominator, so they will cancel, and x times negative 1 will be negative x. Then let's write minus x. Now, this fraction is not a complex fraction anymore because it doesn't have fractions in the numerator or in the denominator. Also, this fraction cannot be simplified more, therefore, this will be the result, y plus x over x squared y minus x. This is the last example of this section, and we need to simplify 4x to negative 2 minus x to negative 5 times y plus 2. This expression is a difference of 4x to negative 2 and x to negative 5 y plus 2. We will start by working on each of these expressions individually. The first expression is a product of 4 and x to negative 2. Number 4 doesn't have a negative exponent, but x has a negative exponent. We will move x to the denominator and the exponent will become positive. But keep in mind that because 4 doesn't have a negative exponent, 4 will stay in the numerator and only x will go down and the exponent will become positive. Now, in the second expression, we also have a product of x to negative 5 and y plus 2. In this product, x has a negative exponent, so we will rewrite this as y plus 2 over x to positive 5. So we will have minus y plus 2 will stay in the numerator, but x will go down and the exponent will become positive. Now we have two fractions, and to subtract them, we have to have the same denominator. One denominator is x to the power of 2 and the other one is x to the power of 5. If both denominators have x raised to an exponent, then the least common denominator will be x raised to the largest of these two exponents. That will be x to the power of 5. And as you see, x to the power of 2 goes into x to the power of 5, and x to the power of 5 also goes into x to the power of 5. So now both of these fractions will have the same denominator, and that will be x to the power of 5. The denominator of the first fraction was x to the power of 2, and now it is x to the power of 5. To build up this fraction, we need to multiply the numerator and the denominator by x to the power of 3. So we will have 4 times x to the power of 3 in the numerator, and x squared times x to the power of 3 in the denominator. Then the new numerator will be 4x to the power of 3. In the second fraction, the denominator did not change, therefore the numerator will not change either. And now, once we have the same denominator, we can subtract these two fractions. So the denominator is x to the power of 5, but in the numerator we will bring down 4x to the power of 3 minus, and here we have to subtract y plus 2. But this negative that we have in front of the fraction is like a negative in front of the parenthesis. It will be distributed to this y, and it will be distributed to 2. Therefore, in the numerator, we will have 4x to the power of 3 minus y and minus 2. And this will be the final answer. Here we will be done with section 11.1, simplifying expressions with integer exponents. Thank you.